of machine. So you all probably know dynamic is very important, isn't it? Because it is dealing with force. All right. Now, before we go to the actual topic, I would like to give you a very quick revision why we need to know the dynamic. All right, so you already studied dynamics in your class. Dynamics, of course, related to the kinematic and also kinetics of machine. Now, let's take, for example, this is a 4-cylinder engine. All right, so we have each cylinder coming to the top dead center at a time. So this is cylinder number 1, number 2, number 3, and then cylinder number 4. All right. So every time when the cylinder go to the top position, for example, number 1 here, there is a spark. The spark will cause a fire and pushes the piston down. All right. When it pushes the piston down, then this shaft will start to rotate. Okay, so when the shaft rotate, of course, this will then rotate and you will turn the wheel. All right, now you can understand that the spark force has a very big force. All right, so this big force create a force on this piston. All right, so this is a piston. So if the piston is not strong enough, the piston will break into pieces, isn't it? All right, then the force need to be transmitted to the connecting rod. This is a connecting rod. Force need to connect it submit to this rod. All right. This rod then go to the crankshaft. This part is a crankshaft. Now each of these must be strong enough to withstand the force. All right. For example, this is the force. Okay. So we call this as a firing force. Okay. If the firing force is strong, and then your linkages is not strong, then you will break into pieces. All right. For example, here now you can see the front view. Now we have piston here. This is a piston. All right. So this is a piston. Then this thing here is your. We call this as a con rod, connecting rod. Okay. And then finally, from this point to this point, we call this as crank. All right, so now we are interested to know the force produced so that we can overcome the mechanism, so that the mechanism will not break apart. All right. Okay, now I would like to focus on one of the cylinder here. All right, and draw a schematic diagram. Okay, so this is the schematic diagram, but now it's in horizontal direction. Okay, so when we have a force will impede on the piston, so this is your piston. All right, now your piston will then move this connecting rod. Okay, this is your connecting rod. All right, so the connecting rod will then push down the crankshaft. All right, so each of these will have a mass. They have a mass, and this also have a mass, and this also have a mass. All right, from our dynamics of machine, we know summation of force equals to mass times acceleration, isn't it? All right, why I say summation of force? Because there are many forces. Force due to point A, we got force due to point B, we got this external force, and we have a force due to friction as well. All right, now to know the force, we need to know acceleration, this acceleration. So acceleration is very, very important for us. All right, so we need to know acceleration at G, at center of gravity. In this case, the acceleration is at the center of this mass. The acceleration is at the center of this mass. All right, acceleration at the center of this mass. Okay. Now another equation, because mechanics is about force and moment. So we know summation of m equals to I0 multiplied by alpha. All right, so you already studied, you already know how to find I. I is the moment of inertia. All right, you already know. And again, this is angular acceleration. Okay, so now you can see, in order to be able to work out the force, you need to know acceleration A, you need to know angular acceleration, you need to know m, and you need to know I. All right, so now we're going to proceed how to solve this problem. Now, since we are on this schematic drawing, now we can see the first thing we understand is the acceleration. For example, the acceleration of the sliding block will move in this direction. So we have acceleration of G4. We call this as link number 4. Now here in the mesh center, we have acceleration of AG3. 3 means link 3. AG means accelerations, all right? Now the angle of acceleration is very important. In this case, we need to draw a horizontal line. All right, so the angle of acceleration start from the x-axis and go all the way to the arrow of your acceleration. All right, so it's not, the delta 3 should be here. All right, now acceleration of link number 2, we call this as AG2. In this case, the angle of acceleration is here. All right, now we can see that the diagram is going to be very complicated. All right, so the best to draw this is to come up with free body diagram. So we draw free body diagram. So we separate into link number 2. All right, so this is link number 2, and then this is link number 3, and then this is link number 4. Okay. Parameters is my acceleration, AG. All right, this is the acceleration. So I must locate AG on the diagram. And I must also indicate the angle of the diagram here. Angle, maybe you must remember, it starts from x-axis, go all the way to the arrow of your acceleration. All right, so we acceleration of link number 4, we need to know acceleration of G3 as well. All right, now acceleration of G3, you can work this out yourself, or sometimes is given. All right, now you see AG3, the angle of AGC start from the x-axis and you go all the way here until you reach the arrow. This is the arrow. All right, so this is your angle delta 3. Okay, now we last acceleration here is your AG2. So AG2 is here, you draw. As I say, this acceleration is given. So either given or you need to find. Okay, or you need to find. All right. So we locate acceleration. So this is your first step. All right. Now your second step is to locate the distance of your center of gravity to a point. All right. So in this case, link number 4 is only 1 point, isn't it? B here, B. So this is only 1 point. All right, B. Now link number 3 has B and also A as well, AB. All right. So we need to identify the distance from the center here to point B. All right. So we call this as radius 4, 3. All right. Now the arrangement of the number is very important. 4 means the R is towards link number 4. Link number 4 is our slider. So the arrow shows that is going to 4. All right. And it's on link number 3. This is link. Okay, now the next one is your R, because your R has another position to A. All right, so A is actually attached to link number 2. All right, see link number 2, isn't it? So this is our link number 2. A is attached to link number 2. So that's why you have 2 and on link number 3. All right, so this is your second step. Now you're going to do the same thing for link number 2. All right, now you have your R towards link number 3, which is R32. All right, on link number 2. And then from the center of gravity to link 1 is a fixed link, so it's R12. All right, so these are the 2 important information you have to locate in your free body diagram. Lastly, another important information you need to locate into your free body diagram is the force. All right, so we have the firing force of the piston Fr. Now we have this force to support this. So this is the force, all right, of link number 3 to link number 4. All right, this is the force of 3 acting towards 4. Okay, now the direction of this force is equal and opposite to F43. 43, that means it is from link number 4 towards link number 3. All right, you must use this notation in this manner, otherwise you're confused. Okay, so 43 is opposite in direction to 34. The arrow is in opposite direction. Okay, all right, now once you have this force on one end on B, you need to find the force at point A here. All right, point A also have a force. In this case, we call this as F from 2 to link number 3. All right, to link number 3. Now this direction of force is arbitrary. You can assume either going up or going down. All right, but then the next force, you must follow your convention. If this is going down, then F32 must go up. All right, in this point. All right, so you have 2, 3, and here you have 3, 2. They must be equal and opposite. Okay, now finally you have this force from the reaction. Okay, F1 towards link number 2. Okay, now you finish the 3 important points. All right, let me repeat here. The first important point is your AG. You need to identify where is your AG. The second important point, you need to find the radius of G, okay, from G. All right, and number 3, you need to identify your force, which is F. Okay, now one important point I'm now going to mention to you is the notation of your force F43. All right, so you will notice that for example, in link number 3, all the notation end with 3. You see F43, R43, R23, and F23. So that's something you have to remember. All end with 3. All right, the acceleration end with 3. Okay, now for link number 2, your force end with 2 and R12, radius also 2, and your G is also 2. All right, so this important information you have to remember. All right, now we need to know how to find, because we already mentioned here, summation of force equals to MA. So we need to know the acceleration. Okay, now I'm going to give you a quick revision on how to find the accelerations. All right, so to find acceleration, I'll just give you an example here. So this link might not be similar to the link we are looking at, but the principle is the same. Okay. Now we need to find, in this case, we are usually given acceleration of A, and we need to find the acceleration of B. So we can say acceleration of B equals to acceleration of A plus acceleration of BA. All right, so we know this relative equation. To find acceleration, you must find acceleration of A or B, then only you can find acceleration of G. Understand? All right. Now, you may also know that acceleration has two components. So we can break this up into acceleration of B normal plus acceleration of B tangential. All right. And this is equals to acceleration of A normal plus acceleration of A tangential. All right, then plus acceleration of BA normal plus acceleration of BA tangential. All right, so you already know this. Okay, now once you know this, your next step is to draw the component of this acceleration on your free body diagram. All right, so we start from acceleration of B. All right, so acceleration of Bn, we know has to go through the center of gravity towards the center of rotation. Therefore, the line is from B to the center of rotation. All right, the arrow, direction of the arrow. Okay, now direction of AB3 is at this moment unknown. So we just draw the direction. Okay, so we just draw the direction. Direction is perpendicular to link BO. All right, perpendicular. So this is, so you just draw that. Okay, now we need to go to acceleration of A. All right, acceleration of A, you have acceleration of A normal, go from A towards 0. The direction of arrow is going down. That's what I draw here. Okay, and because the rotating is constant, therefore this term is 0. Okay, so we don't have to draw the component at point A. All right, now we need to draw acceleration of BA normal. BA normal is actually in this line here. All right, but it's too many lines, so I draw another separate line, AB. I draw it separately here. So BA normal is drawn towards from B towards A. All right, because from B to A. Tangential, I draw the direction because I do not know the arrow whether it's going up or going down. So I just draw the direction, which is perpendicular to this link. All right, it's easy. Okay, so once you have all these components drawn, we then have to work out the magnitude. So first, let's look at acceleration of here. Acceleration of A normal is equals to R2 omega 2 square. All right, so omega 2 square is given 20 and R is given, so we know this value. Now, acceleration of B normal, we can also know because it's given by R omega 4. All right, omega 4. And acceleration of BA normal is R omega 3. Now you can see we got 2 omega. Okay, now this omega you have to find from your velocity diagram. Now I'll show you the velocity diagram. Okay, we have two methods. The first method we can use instant center to find the velocity, and the second method we can use the graphical or analytical technique. All right, so I'll show you the first method first. We use instant center method. So you have to draw this drawing to scale. Okay, you have to draw a scale drawing of a mechanism. Then you do the construction of A. Acceleration of A is going this way. okay, perpendicular to the radius. Therefore, you can construct this line here. All right. Now, acceleration of B is also perpendicular to this link. Therefore, you can construct this link here, perpendicular. All right, maybe is, yeah. So along here. Okay. Now it's out of the paper here, so I just extend it. All right. Once you can draw this triangle, we know the ratio of this link, all right, over this link. Then we can find the velocity of omega 3. All right, because we know omega 2 is given here. Okay, omega 2 is given. All right. So this ratio is inversely proportional to the ratio of the link. All right, so you can find this link, isn't it? So you see 163.76. All right, you can use this. Now B also the same. All right, B we know, now we know omega 3. All right, so this one, omega 3 multiplied by this distance, which I measure to be this value. All right, therefore you can find omega, you can find velocity of B. But we need to find omega 4. Now, if you know velocity of B, okay, here you substitute B, you divide by the radius, which is given L4, 122, change to meter, you get 5.4. All right, so we have two values. So one value is 4.9 and the other value is 5.4. Okay, so you substitute these two values into here, omega 4, which is 5.4, omega 3, 5.2. All right, then you know these two values. You can find omega n, and you also can find omega n. The acceleration of n. Okay. Now we're now ready to use our core construction method. Okay. We use graphical construction. Okay, now we know the value. You have to draw this to scale. We use a scale drawing. Okay, so your first value is 16. Acceleration of A, normal. So acceleration of A is, can you see, is going towards the origin here, going downward. So we draw acceleration of A here, O, all the way down. Hello, can you hear? Hello? Yes? Anything? Okay. All right, so acceleration of A, we just find out this is equals to 16. All right, so 16, you see, I draw this thing here, 16 is parallel to this link here. So I draw parallel. All right. Then, because I draw to scale, I can stop at point A. All right. Because I start at point A. And then, I know acceleration of B normal. Acceleration of B normal, which is given by 3.56. So 3.56 here. All right, I draw all the way down, 3.56, and it is parallel to this line here. All right, parallel. All right. Now I draw a perpendicular because I do not know. So the perpendicular can go this way or can go this way. All right. So it's more likely it go this way. All right. So we can ignore this part. Right, and we do not know this length. So we just draw a line. To find the intersection, we now need to know BA. Okay, BA is drawn from point A towards B. BA, we already found from here, BA here. All right, it goes in this direction from point B to point A. The value is 2.6. All right, from point B to point A. So we look at point B, from B. We draw from this point here. BA is towards from A to B. All right, from A to B. From A to B, you draw this line, 2.6. All right, now you can construct this perpendicular all the way up here. You meet at this point. All right, now from this diagram, you can find AG because For example, link number two is acceleration of A, isn't it here? All right, link number two, assuming the center of gravity is in the middle here. So you can draw here all the way down in the same direction. This is the B, this is G2. All right, so this is your A, G2. Okay, now G4 assume is in the middle of this link as well. All right, so it's in the middle of this link. So it's from point towards point B. So this is your total result for B, acceleration of B. So you draw here. So this is your G4. Sorry, G3. Okay, so this is your G3. All right, so you measure the magnitude, so this become your AG3. All right. So, sorry, this is G4, I beg your pardon, this is G4. So this is AG4. AG3 is on this link 3. All right, link 3, assuming it's in the middle of A and B. All right, in the middle between A and B, somewhere here. So this is our G3, middle of A and B. So middle of A and B is somewhere here. All right, so this is your G3. Now you draw a line here all the way to the origin. All right, so this is your AG3. Okay, and this is your angle of your acceleration. All right, so now you know how to find AG2, AG3, and also AG4. You need this value for your calculation. All right, so once you know your AB tangential, you can find your alpha 3. You need alpha 3. You also need alpha 4. Because remember, I mentioned summation M equals to I alpha. All right, I is usually given, so you need to find this value. And now we can find this value from this calculation. Okay, now you got any questions, student? Am I going too fast? You understand? Can someone tell me? You okay? Now, if you're okay, I want to show you the last method, how we use the analytical method. All right, so this is our analytical method. So I've already shown you graphical. Now I show you analytical method. Okay. So analytical method, you have to break your component into, again, tangential and normal component, like what I did before. All right. Now we then solve this separately. We said B first. All right. So acceleration of B here. And then we know the equation is R alpha J E theta. All right. And here is R alpha E theta. All right. So you can see J is the imaginary axis. All right. So this is the real axis. I use a different notation rather than I, J, K. Okay. So I use real, which is I, and imaginary, which is J. All right, so I'm sure you study in the math. So you can substitute R alpha J, can you see J? And theta 4 is cos theta 4, J sine theta 4. All right, and this value here is cos theta 4, J sine theta 4. You just substitute the value. Right, you substitute your angle and then use your multiplication. You can then come up with this equation. All right, so this is your equation number 1. All right, so you can do the same thing for this time for acceleration of A. Okay, acceleration of A. So acceleration of A is given by this equation. All right, we substitute the equation. All right, now this is equal to 0, yeah, because there is no alpha constant. So we have only the omega component, right? You substitute your value, you find the value here. Okay, so lastly is this value. All right, so here we have BT tangential and BA normal. We use the equation, we substitute the value, then you end up with this equation number 3 and this equation number 2. Okay, now how to find the value? We then use equate the real part. All right, the real part, that means there is no j. Okay, the real number. So acceleration of A, the real number of the acceleration of B. Yeah, look at, so is the real value for the real part. The real part, are we equal? Okay, the real part is here. Acceleration of,
Hello.
yeah?
Why is it minus between the tangential and the normal component, but you wrote plus at the general equation?
Okay, all right. So that is a good equation. That's a good question because you find that here omega square times omega square, so it's minus. Okay, all right. So I put there because I haven't entered the vector value. Once I enter the vector, it becomes minus. Okay, that's a good question. You must know, yeah. So actually, it's omega k multiplied by omega k. So k cross k is minus 1, isn't it? Yeah, I hope you remember this. Omega
Sir,
square,
but
k cross k
I
is
thought
minus 1.
we are doing in the complex form.
Yeah. Because now I don't put the word k now because omega square. All right, so you can see why is minus, because if you look at this, our radius is actually going up, yes or no? Yeah, the vector for radius is up and the velocity is coming down, am I right? Okay, because the vectors are different, therefore you have minus there. Okay, you have all these minus sign. All right. All right, so there's something you have to remember. Can you see it? All minus, okay? So this is actually in your mathematics. All right, I hope you can revise your maths. All right, so if you revise your maths, you know that all the omega become minus, you see? All right, minus. All right, it's in your maths. All right, so please go back and refer to your maths. Yeah, as I also explained, we are only use I and J, but you know, so this is your I, so this is the I and this is J. So the rotating axis is here. Okay, so this is your K. So this is your omega. All right. So I have no time to go through with the vector analysis for you. All right. I assume that you can understand. All right. So that's why I got all the minus signs in it. Okay. You substitute the value. Now you finish those. You then equate the real part. All right. So you equate the real part. So omega B here, the real part for omega B is, in this case, is this value minus, and the real part is this value. All right, so you enter this value here, the real part, can you see it here? All right, and then A is the real part for A is minus this value 88.74. So you got minus 8.74. The real part for BA is actually minus 2.6. So you minus 2.6 here. All right. So from this equation, you can work out alpha 4 straight away. All right. Now, if you equate the imaginary part, which is a J component, so first your B has this value and also this value. So you enter these two values here. There you see here and here. All right. And A, acceleration of A is given by this imaginary 13.4. So here you got 13.4. All right. And this is here. Here. Okay. This is here. Right, so you rearrange, you can work out your alpha 3, and because your answer here is positive, then your direction is counterclockwise, okay, which is this direction. All right, here also positive, therefore your direction is also counterclockwise. All right, if it's negative, then it should be clockwise. Okay, if it's negative, then it's clockwise. All right, this is thing you have to remember of your assumption.
So
All right,
if
now you have,
so
yeah,
if you
hello?
solve using the equation already, no need to sketch the diagram again, right?
No, you have to sketch the diagram because you cannot find, you are now going to find your AG, isn't it? Yes or no?
Okay,
All
okay.
right, you only find acceleration of A and acceleration of B, isn't it? And acceleration of ABA. All right, you only find these three values, but you haven't find acceleration of G. That's what we want to find. All right, now let me demonstrate to you how to find acceleration of G using this diagram. I hope I have this diagram here. Yeah, here. Okay, now we know from our calculation acceleration of. Now you see your first of all, let's look at acceleration of B. Acceleration of B is given by these two components. Okay, which is the real minus 11 point and imaginary is minus 2.3. So I draw this thing here. So I draw acceleration of A. Can you see my acceleration of A is here? It consists of these two components, minus 13.4 and 8.4 here. Okay, here is it, minus 11.4 and 2.38 here. So I draw here. This way is, yeah. So sorry, that is the acceleration of B here. Okay, so my first value is acceleration of B, yeah? Acceleration of B is given by this. So I draw acceleration of B, the y-axis, 2.38, and the x-axis is 11.63. Okay, so I draw, then I can draw the vector of acceleration of B. Understand? Now, I go to acceleration of A, which is this value here. Is the acceleration of A has minus 8.7 and minus 13.4. All right, so I put minus 8.7, which is the real axis, yeah. From here minus, and from here minus as well. All right, so these two x and y, I can find point A. All right, now once I find A, B, I just join the line here. So this becomes my AB. All right, if you want to be sure, you can now use this vector. Okay, you will get the same thing. Then your vector should start from here. Okay, so you'll get the same idea. Now, how to find AG, acceleration of center. All right, so AG2 belongs to link number 2, so it's here. So you locate the center, then you draw this line here. Then this is your AG2. All right. Now B is 4, isn't it? So this is your G4. All right. So G4 in the middle. Assuming the thing is in the middle, yeah? All right. So we need to find AG4. So 4 is the middle of the link here. You draw this line here, then you get your AG4. So this magnitude is half of this magnitude because it's in the middle of the link. If it's a 1/3 at the distance 1/3, then you divide this by 3. Okay, right? Now you find AG3. AG3 is in the middle of A and B. So in the middle of A and B. If it's not in the middle of A and B, take for example G3 is somewhere here. Okay, so G3 is closer to B, isn't it? Whatever distance. So G3 may be somewhere here. All right. So you can draw. So this is G3, then you can draw. So this is your AG3. Depending on this center of the gravity. Understand? Yeah. Then you can find all this value. So from my drawing, I got all this value. I need this value for my dynamic analysis. Okay, now we have already spent quite a lot of time, 3/4 of an hour before we even solve the problem. All right, so I'm going to go through to solve the problem we have to do. Okay, now we are given this linkage. All right, the dimension of this linkage is given here, A, and A continue here, and then A continue here. All right, so here is a given dimension for link 2, link 3, and then you are given only link 2 and link 3 because it's only in a slider crank. All right, now I can see the other important point is a mass. You are given M2, M3. All right, now you are given omega and alpha. Okay, now the other thing is your radius, RG2 and RG3. All right, so we know the direction of the center of gravity. All right, now we have RP3 and RP. That's the angle of the force. Now they are all zeros, isn't it? So this one we can ignore. All right, so we can ignore these two values. All right, so we are only given this, so we know the direction. In the third row, we know AG2 and we also know AG3. All right, and we also know the angle. All right, so AG4 we also know, and we also know the angle, the direction. So this means that AG4 is here, 180 degrees. Okay, so this AG3, so if I draw this line here, AG3 is 200, so it's somewhere here. AG3, so this angle here, 200.84. All right, same for this one. All right, now I'll show you how to solve this problem. Okay, so student, I want you to pay attention to how I do this. Okay, now what I did is I already know the dimension for link 2. Okay, so this is my dimension for link 2 given, and this is my direction for link 3. And so my direction for link 3 also include this angle here. They're all given. All right, so this is my link 3 and this is my link 2 and this is my link 4. Okay, right? So you got to draw the free body diagram. So I just draw the free body diagram. So your first step, number one, you got to draw free body diagram to scale. Scale means you also have to know the angle of the link. All right. Now step number two is your acceleration component. You have to identify where is your acceleration component. So AG2 is given here. This is AG2. And the angle is also given. Okay, you can refer this to your book. Now AG3 here. And the angle is, remember I showed you already, 200.4 from the horizontal. So we know arrow to the arrow. Right? And we also know AG4, 180 degrees. So we draw from here. All right. So your next step is radius to point G, radius to G. All right. So the radius to G for link number 4, there is no radius. All right. Don't worry about. So link number 4 is okay. Now for link number 3, the radius is given because you know where is G4, G3 is given. All right. From given value, you can know your R43. 43 that means towards link number 4 and is on link number 3. And we know the direction. You must know the arrow direction. Okay, it's very important. R23. All right, so you have to draw the direction of the arrow. So this is given. All right, you do the same thing for R32, and this value is R12. Okay, so you can see my R12 is equals to minus RG2. RG2 is given. R12 is not given, but from the given value of RG2, I know is minus R12. They are in opposite direction. All right, so you have to remember this. Okay, all right. Okay, so then you have to insert your force. Now your force value is arbitrary. Arbitrary means you do not know where it goes. All right, so I can just simply assume. Now usually the normal force F1 on 4 is perpendicular. Okay, we know this. And F34, that means towards link number 3, I can assume it's going up. Okay, you can assume it's coming down as well. There's no problem. But then when you come to this point, this has to be opposite direction to this. So my assumption is F34 going up. And now you see my F43, I reverse the direction. So my direction is reversed. All right. But make sure it's still parallel. The two links are still parallel to each other, but only different in direction. Okay. So the next one is F23. That means link to the fourth link number 2 on link number 3. So I can assume this is going up. I can also assume this is coming down. So F23. It doesn't matter. But then when I draw here, F32 has to be upward. Because I draw up here, so my F3 minus, then you know your assumption has to change. Okay, so F12 also the same. I just arbitrarily assume is this direction. All right, so why we need to know this force? Though these forces are very important because as you know, your link is connected. For example, I draw this here, and then we connected to this. All right, so if the joint here, which is your force, is not strong, your joint will break, isn't it? Yeah, here also the same, your force. All right, so you want to make sure that your force is strong enough. That's why we want to find force here. Okay, now we go back to our step-by-step procedure. The first step, so please follow my step procedure from the textbook. Is very lengthy, but it's the same. You got to write these two equations. Okay, summation of force equals MAG, summation of T or summation of M is equals to IG alpha. Okay, you then insert all the given value. These are given. Okay, yeah, these are all the, put all the given value on the table so that you won't miss out. All right, now you got to solve individually, separately. So we first look at link number 2. All right, so the procedure is, first of all, you got to resolve the radius into x and y axis. So the radius into x and y axis. All right, because the angle is given, in the magnitude is also given, you can know the x component and y component. Same thing for R32. R32 is the radius. Can you see the radius of 32 here? 32 here. R32. All right, that is the radius, R32. So we go resolve into x and y axis. Now R12 is here. We have the x and we have the y axis. Understand? You resolve the x and the y axis. Okay. Now these are the things you got to find: F12x, F12y, and F32x and F32y. Okay. Now the equation of summation of force equals to MA, so summation of force in the x direction equals to MAX. All right, this is summation of force in the y direction. So this here is summation of M. All right, now the sequence of this is easy, just sum of the x component, MAGX, just sum of the y component, then you have your AGY. All right, but the important thing when you do your moment, okay, your moment is always R, moment your radius times force, isn't it? All right, so radius 1x times F12y. Then you have minus R12y times F12x. All right, same thing, 32x, 32y, and then 32y, 32x. Okay, so there's a minus sign here. Okay, I have no time to derive the equation. I think your lecturer may have derived the equation for you and also show you why this is minus. All right. Okay, I'm not going to explain, otherwise we have no time. Now, if there's a given value of torque, you got to insert. All right, so we assume positive going counterclockwise. All right, if the given value is clockwise, then it has to be minus. Okay, now eventually equals to I alpha. We know summation of M equals to I alpha. And this is link number 2, so that's why we have alpha 2. All right, so we have these 3 equations. Now you go on to the link number 3 now. So we work on link number 3. Same thing, you got 3, you got the radius, isn't it? You got 3, 2, and you got, 2, 3, you got radius 4, 3. All right, resolve this into x and y component. Right, 2, 3, resolve into x and y, 4, 3, resolve into x and y component. All right. Now, acceleration AG is also given. You resolve into x and y component as well. Okay. Now, you then insert this equation you got to find. All right. So over here, you have summation of fx, summation of fy, summation of m. Okay. So you put in your given equation here. Now, there is a given torque there, so you include the value. Otherwise, it's Rx times Fy, okay, minus Ry times Fx. So this sequence is the same as all the equation there. All right, so you have to remember this. And again, I alpha 2. All right. Now you go to the next link, link number 4. Right, link number 4, we have to find this value fx and f1 rather than two value. Okay, we are given ag. We got to find agx and agy. There's no agy because it's 180 degrees, isn't it? All right, and we also given mu is equal to 0. All right, so for here we got summation of fx, summation of fy. Summation of m is equal to 0 because the cylinder doesn't rotate. All right, so based on this 8 equation, we can construct a matrix like this. Okay, so this is the, so this is say my this, so this is the force you want to find. All right, let's say this is a C matrix. C matrix are all the force, okay, and the radius, and then this is the given these are given value, which is acceleration, mass times acceleration, or the given value. So this is F, this is what you have to find. Okay, now let me briefly explain to you how to construct this table. To construct this table, because this is an 8 by 8 matrix, so you resolve 8 rows and 8 columns. All right, so this is an 8 by 8 matrix. Now you list of F1 to X, F1 to Y, F3 to X, F3 to Y. Okay, and F4 3 and F4 3Y. Okay, and then you have 1 4 and 4 1. Now one thing I want you to remember is, okay, maybe I'll tell you later. All right, so now we go to the first equation here, equation number 1. Equation number 1. Okay, so equation number 1 is this value, f1 to x and f3 to x, f1 to x plus 3 to x equals to m2 agx. So here m2 agx is given value. Okay, we have f1 to x and we have f3 to x, isn't it? See, f1 to x here, f1 to x, f3 to x. So f1 to x and f3 to x. So 1 to x is in position number 1, therefore you have 1 there. f3 to x is in position number 3, so you have 1 there. And the rest are 0. Okay, now we go to the second equation. All right, so you have to remember this, yeah? The second equation is f1 to y and f3 to y, and equals to m2 agy. All right, so 1 to y and 3 to y. So here equals to this value. So you put this value there. Now we got 1 to y, which is in the second place, so here. And 3 to y is in the fourth place, so you have a fourth place here. All right. Now then you come to your equation number 3. All right. So equation number 3, we got a mixture of R and F. R and F. All right. R is a given value, F is an unknown value, isn't it? Okay. So we have to use the R to Y, and then we have F. Okay? So the F is bring onto the column matrix. Now this value becomes IG alpha minus T12. All right. So when you look at this here, okay, you put the known value on one side. Okay. Now F1 to Y multiplied by F1 to X is in here. So F1 to X, F1 to Y. Okay, so first let's look at the Y and the X, yeah? F1 to X. So F1 to X here and F1 to Y. So here you look at your, sorry, R1 to Y and F1 to X. Yeah, but it's minus, so I forgot to put minus here. Okay, so this is also minus and this is also minus. Yeah, so just add this into the value there. All right, and the rest are 0. And finally you have a 1 value here. Okay, the one value is the one value is for your F12 here. All right, we have this value. So you end up with this column here. All right, so this is your third row, third equation. Fourth equation, this fourth equation, fifth equation, sixth equation. So here we got 4, 5, and 6, which you then enter here. Okay, and then 7 and 8. So this is 7 and 8. So here is 7 and 8. All right, so how to find this? So F is equals to C minus inverse multiply, say this is my R, multiplied by R. All right, now this is very lengthy for your hand calculation. So normally you have to use a MATLAB. Okay, and you may also have some calculator, some scientific calculator, but you cannot bring this in your exam, isn't it? All right, so I heard that the lecturer say that you just have to know how to derive up to this point. You don't have to work out the value. Okay, once you know how to work out this matrix, it's enough. Your question is finished. To work out this is a very, very lengthy process. Understand? Now, I'd like to go through the solution of this. Now, the solutions are given here. So you find that I want you to go through yourself. All right. Now, the main thing is it also resolves into 1 to x and y. X and y, he resolved all the radius, same as what I did. Yeah, but I did link by link, okay, but they lump all together here. All right. Then the next thing, you got to do your acceleration, isn't it? Like what I did, AG. Okay. Okay, what they do is that they put all together, but for me, I put it into link 2, link 3, and then I separate into link 4. Okay, but the procedure is the same. So the procedure, as you can see, is same. They have C matrix, and then they have the F matrix. All right, R is what you have to find. Okay, so you can go through this for your revision as well. All right, then this is your answer. Okay, yeah. Then from the answer, you know the x and y, so you can find the total value. Because these are vector. Okay, these are vector, okay? So vector, you cannot just add straight away. Okay, you got to use the here. All right, so I'm sure you know how to find the resultant of a vector. Okay, student, I know I'm going on this for 1 hour, so it's very hard for you to focus. You got any question to ask me before we stop? Student?
So I got the question on the previous tutorial.
Okay, yeah, you can ask me, but I don't know how I can insert your attendance now. Okay, so what's the question? So what's the question?
On the tutorial 1A.
Tutorial 1A, yes.
Question 8A.
Huh?
Tutorial 1A, question 8A.
Question 8A. Okay, let me have a look.
Yeah, like the full join in the answer show is 15 full join, but I only like calculated like 14. How to get 15? Yeah, 1A.
Tutorial 1, question number 8. Let me go through. Yeah, question 8, yes.
8A, the
yeah.
number of full joins and the solution is 15, but I calculated, I get 14. Like how to get 15?
Okay, I don't have all the solution, but they are all single degree of joint. So do you consider 12 and 11 and 12? There's a link 11 and 12. Do you have what 11 and 12?
So do you have the solution, the PDF solution? Maybe you
I
can
think
use
the
show the.
solution I wrote it on the board, isn't it? Yeah.
Yeah, you have the PDF now. Maybe you can show the PDF.
I have to see whether I can upload this one or not. I need to go to.
So I put at the chat box already. You can go there.
Huh?
Refer to that.
Yeah, someone already insert at the chat box.
Okay, can someone load the solution, then I can explain?
What you mean load the solution?
Okay, can you upload on the screen, because I have to go to my file.
You mean share the screen?
Yeah, can you share the screen? Yeah, sorry, can someone share the screen?
Okay, I will share the screen.
Yeah, you share the screen now, I'll explain to you.
Yeah, this is the one, like, I can't get the 15 full joints.
Which one? So I can't see. Yeah. No, I have to get out of my screen first, isn't it? Oh, so this one is your screen, isn't it? Okay, let me see whether I can enlarge it. Yeah. Okay, I can't draw here.
Not really. You cannot draw.
Yeah, I cannot draw. But I just want to explain to you. You have a link 1 and 2. Can you see? Let's say link number 2.
Sir, or do you have this file with you? Maybe you can open the file at your computer and you can draw there. Like this is easier.
Okay, I will go. I will log out first.
Okay, thank
Okay,
you.
so you log out first, then I'll see whether I can attach. Okay, I can't attach this file now. I cannot attach the file.
Yeah, now I see your screen.
You can see my screen, but I have to go out and then I then have to go out and then log in again.
You can just open at the whiteboard, right? The PDF, like how you usually share the screen.
You can see my thing there.
No, sir. No, I don't see anything yet.
Okay, you don't see anything yet, isn't it? Okay. Can you see the screen?
Yeah, now
Yeah.
I can see the whiteboard.
Okay, I can just roughly draw this to you. All right, so you can see this one. 2, 3. And then this is link number 4. Link number 5. And then we have this point here. Okay, so link 3, 9, and here. Six, 7, 12. Okay, can you see all the link now?
Can.
Yeah. All right. So now you have to identify, for example, 1 and 2. Okay. Now you have 1 and 4. Here you have 2 and 3. All right. And here you have 4 and 9. Here you have 3 and 7. 3, 7. And then here you have 5, 7. And here you have 8, 9. Here you have 9 and 12. And here you have 11 and 12. Here you have 10 and 11. And here you have your 9 and 10. Four and 5. Okay. And here 5, 8 and 3, 7. All right. So now we have all these points here. So you can count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1, 6. 6, 7. All right. So how many points now? Can you count? 1, 2, 3, 4, 5. Six,
14, sir.
huh? 14. Oh, here 4, 9, 2, 4, 4, 5. 4, 9, 8, 9. You got 9, 12, 11, 12. You got 9, 10. 1 6 6 7 3 7 3 7 5 7. So there's 1 5 8 5 8. Yeah, link number 5 and 8. How many now? How many links now? 14, 15, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, 15. Can you see 15? Yeah?
Okay.
You miss out, can you know now?
So, but like the at 5857, that one, right?
Yeah.
That joint is 2 degree of freedom, right? 2 degree of freedom system.
No, it's 1 degree of freedom. But they just have 2 joints there. 2 joints on one link. Okay? So it's just so this point here. So you can imagine 4 is a triangle link. Okay? So 4 and 5, and then 5 and 8. All right? So 3 is moving here, 3 and 7.
Okay,
Alright.
I think I missed out the one at the 58 there. Okay.
Oh, okay. Yeah.
And so one more thing,
Yeah.
for the crank slider, right?
Yeah.
The angle between the link. Wait,
Yeah.
I open the file again. The angle between the. Maybe I share my screen.
Yeah, you can share screen, yes.
For 4-bar crank slider, right? Is the angle theta 4 always equals to 90?
Which one? Let me have a look. Have you started your presentation?
I share my screen
Yeah,
already.
okay, yeah. I see your screen, yes.
For the angle theta 4, is it always equals to 90 degree?
No, because this happened to be given here.
But if no, right, the equation here is only given to calculate the theta 3.
You see, this is the off-screen mechanism, right? At this moment you can see the theta, all right?
Hello, I can't hear you.
Okay. So you mentioned that theta 4, is it always 90 degrees?
Yeah.
No, not necessary. Not necessary. So in
But
this example is given is a parallel. In this case is given.
yeah, but my concern is if it is not necessary to be 90, right? Then
Yeah.
how do we calculate, like the equation is only given is to calculate the theta 3, right?
That's why sometimes I tell the student that the equations are very arbitrary. The equation is very arbitrary.
What do you mean very arbitrary?
What I mean is you can assume to be 90 degrees, or you can assume not to be 90 degrees as well.
How we make the assumption on this?
I don't know whether I can draw this thing here. No. So I go back to my whiteboard. I show it to you. Okay.
Okay.
Okay. Let me upload. Can you see my whiteboard? Yeah? No, no, okay. Let me try again. How about now?
I still can't see anything yet, sir.
Can't see anything yet. Huh?
Mm.
Okay, now?
Yes, loading.
Okay, so you can see, yeah?
Can.
Okay. Now, so this is the, I can't quite remember how to draw your link now. I can't quite remember how to draw. Let me see. Is it like this? And then here, is it something like this? Yeah?
Yeah, something like this. Yeah.
So this R2, isn't it?
R2. Uh,
And then let me redraw.
the
So
ground
R2
is
is longer. Huh?
at the slider there, so the
Oh,
ground.
okay, okay, okay. Yeah, R2 is on the slider. So if I draw this thing here,
No, what I mean is
is it like
this.
this?
No, sir.
Okay, you are saying this is 90 degrees, isn't it?
Yeah.
Okay,
The angle of the R4 between the
yeah, what's
x-axis
the
and
angle of where is the location of R2, the O2?
I share the screen to you to see.
Okay, you share your screen.
You see the screen also.
Not yet.
How about now?
No, I think maybe I have to get out first, isn't it?
Yeah. Maybe you switch off your
Okay,
screen.
okay, I can see it now.
Yeah, this the one.
Okay. So you can get off, so I can draw my screen now.
Okay.
Can you see my screen?
No, still not yet.
About now?
Yeah, loading.
Okay. So this is your location of your R2, isn't it? So this is R2, and then here is your, and then here's a slider, isn't it?
Yes.
Something like this, yeah? So this is R3, isn't it? Am I right?
Yes.
So from the text, and then they say this is R4, isn't it?
Uh,
This is R1, yes?
mm,
Isn't it, yeah?
yeah, like this.
Okay. Now, this is actually on position analysis. So if I draw this, so if you follow my arrow, yeah, so R1, so I can write the equation R2 plus R3 minus R1 minus R4. Okay. Now the reason why I say this is there are many ways to look at this problem. All right. There are many ways to look at this problem. So your R4 actually if you combine, you can combine this into say R5, then let's say R5. So R5 is equals to R1 plus R4, isn't it? Okay, maybe I'm a little bit confusing you now, but as I said, not necessarily must be 90 degrees here.
But why do we need to have the additional R5?
R5 is a resultant of these two to save the problem.
Yeah, I understand. Like if I understand, but in the mathematical way, yeah, but like in the engineering way, why do we need the additional R5 there? Just to make the 90 degree?
No, you don't need to. Once you reduce this from this equation, you can come down to R2 plus R3 minus R5 equals 0. All right. So the other alternative is you can say R2 plus R3 equals to R5 based on this one. And based on this one, R2 plus R3 equals to R1 plus R4.
So actually, what's the difference? It's just like just a method of writing?
Just a method of solving.
Oh, we just combine the R1 and R4 become the resultant to solve.
Yes.
Oh.
So you can do this. So that's why I say R4 not necessarily must be 90 degrees.
Okay.
You get it?
Okay.
Yeah.
Okay.
The book use 90 degrees easy to illustrate.
Oh, so basically is they just combine the ground link and the output link become one?
Yeah, that's right. That's
Okay.
right. It's just combine. So it must, because these two distance are given. R1 is given, R4 is also given.
So the angle of the R5 from the x-axis, right? We get from
R5 will be from this axis, theta 5.
We get from the triangle identity.
Yes. So
that's why no
every
equation.
time, yeah.
Okay.
So you see, every time your position changes, so your R5 is also changed.
Okay, understand.
Yeah, okay. Mm.
Yeah, that's it. That's all from me. The questions.
Okay.
Thank you, sir.
All right. So any question? If not, we stop our lecture today. Okay? Yeah, I'll stop recording now.
Sir. May we ask about the midterm test?
Pardon?
Midterm test.
Hello? I can't hear you. Say it again.
Can you ask about the midterm?
Midterm test?
Yeah, to confirm the coverage until you check the.
Oh, that one I'm not really sure. I have to check with Dr. King.
Oh, okay.
Yeah, I'm not really sure what is his plan.
Okay, I see.
Okay. Okay, students. So we'll stop here today, and if you have anything, you can always send in the chat. Okay. So there are some students corresponding with me using the team chat as well. All right. So you can use the team chat.